Hello students, in this video we shall discuss the LTC AIIMS Chemistry Weekend Test Paper solution. Let's start with question number 1. If the cell edge of FCC unit cell of a metal is 8 under root 2 picometer, the radius of the metal atom in picometer is. Now, for a face-centered cubic unit cell, the phase diagonal, which is under root 2a, it is also equal to 4r because one particle is at the face center and two particles are at the corners, right? So root 2 is equal to 4r. You substitute the value of a, the edge length, and then you find out the value of radius. That will come out to be 4 picometer. Next question, the crystal system which has all four types of unit cells is orthorhombic. You should remember the types of possible variations in all 7 crystal systems. Possible variation for a cubic crystal is primitive, face-centered, and body-centered. Okay. The axial angles of a hexagonal crystal systems are these. Yes, this is correct, but this one is not. So the above statement is true. Which one of them is true? Yeah, only second. That is the correct answer. Niobium crystallizes in BCC structure, and for a BCC unit cell, the number of atoms per unit cell is 2. Okay, so the mass of the unit cell is 2 multiplied by mass of one particle, which is 93, multiplied by mu. It is nothing but the reciprocal of Avogadro number. So this would be your answer, which will come out to be this one. An element occurring in the BCC structure has 12.08 into 10 to the power 23 unit cells. The total number of atoms, of course, because each unit cell of BCC contains 2 atoms, so the number of atoms would be twice the number of unit cells. So this would be this. That would be the correct answer. Okay. There is only one way of arranging spheres in a one-dimensional closed packed structure. Yes, linear arrangement. In one-dimensional closed packed structure, the coordination number is 2. Yes, because if you arrange particles along a straight line, then any particle touches two particles, one at its left and other on the right. So both statements are correct. A compound is formed by the cation C and anion A. The anion form hexagonal closed packed structure, and in HCP unit cell, the number of atoms per unit cell is 6. The cations occupy 75% of the octahedral voids. So for 6 atoms per unit cell, number of octahedral voids would be 6 only. And because 75% of the octahedral voids are occupied, that makes it 3 by 4. You solve it, the ratio will come out to be this one. Okay. So 6 will be cancelled out. It will be 3 is to 4. So the formula is C3A4. A metal has BCC structure, the edge length is given. The volume of the unit cell, we are assuming the unit cell to be cubic. Yes, because body centered cubic. So volume would be edge length Q, and angstrom in terms of centimeter is 10 raised to the power minus 8 centimeter. So you just calculate the cube of this number. So this would come out to be the correct answer. If A is the length of the side of a cube, the distance between the body centered atom and one corner in the cube. Okay. So for a cube, the body diagonal which joins two diagonally opposite corners is root 3a. All right. So for instance, if this is the cube diagonal AB, so its length is root 3a, and if we consider the distance between the body centered atom, so it would be placed here, the center of the particle would be here, and one corner atom, so corner atom would be here. So you can easily figure out that the distance is root 3 by 2. Coordination number of CCP unit cell, it is 12. Any given particle touches 6 particles in its layer, 3 particles on the top layer and 3 particles in the bottom layer. A compound formed by Mg, aluminum, and oxygen is found to have cubic flows array of oxide ions. You can find it out. Of course, this formula fits as per the charge neutralization. But let us just calculate the ratio. Oxygen forms CCP, so it is 4. Mg occupies 1/8 of the tetrahedral voids. So this is the number of magnesium. And aluminum occupies half of the octahedral voids. So it is half into 4, right? So this will cancel out. So 1 by 4, 1 is to 2, and then this would be 1 is to 2 is to 4, right? In FCC arrangement of A and B atoms, atoms A are at the corners of the unit cell, so it is 1, and B atoms are at the face center. So there are 6 face centers, and each face center contributes half to the total number of atoms. So technically the ratio is 1 is to 3, but one of the A atoms is missing from the corner. Now you guys know that in a primitive unit cell, there are 8 lattice sides, okay, and each corner particle contributes 1/8 of the atom, right? So because one of the corner particles is missing, so 1/8 would be subtracted because each particle contributes 1/8. So A would be 7 by 8, 1 minus 1 by 8, okay, and it would be 3. So the formula, resulting formula of the compound would be A7B24, okay. In which of the following reactions of aniline, the benzene nucleus is not attacked by a reagent? Reaction with bromine water, reaction with acetyl chloride in presence of pyridine, reaction with corn sulfuric acid, reaction with nitrating mixture. So you can find out, we are talking about that benzene nucleus is not attacked. So when you carry out the reaction of aniline with bromine water, yes, three bromine atoms get attached on ortho and para positions. In corn sulfuric acid, yes, first a salt is formed and heating leads to the rearrangement, migration of the sulfate ion to the para position. And as far as nitrating mixture is concerned, yes, if you carry out the nitration of aniline, then you get a mixture of ortho, meta, and para products, right? But in case of acetyl chloride, the reaction with acetyl chloride, the reaction occurs at NH2 group itself, right? The NH2 group gets converted to NHCO CH3. Okay, so this is the correct answer. First, you carrying out the acetylation, the reaction we just talked about. So it is NHCOCH3. Then you carry out the bromination because of the controlled activating effect and also the steric hindrance at ortho position. Now, incoming bromine it enters at para position, and when you carry out the hydrolysis, acetic acid is separated, and you get back your NH2 here. So the correct answer is this. Aniline, when heated with concentrated H2SO4 at high temperature for 3 hours, finally gives this sulfanic acid. In fact, it exists as a deuterionic structure because it has a basic and an acidic group. Reactivity in coupling with diazonium salt is maximum when the substrate is aniline. Of course, because diazonium salt is an electrophile, and coupling reaction is an electrophilic substitution of the nucleophile, of course, and the most activated ring here is in aniline. The stability of arene diazonium salt is explained on the basis of resonance. Which of the following is incorrect? Of course, this structure is not possible because how can we have sp3 hybridized carbon in the benzene? So that is the incorrect correct option, and incorrect resonance structure. So NO2 is reduced with zinc HCl, that gives you aniline NH2, and then you carry out the diazotization, that gives you diazonium salt, and then you react it with HbF4, that basically converts into NO2, right? Okay, so the next question is, Sandmeier's reaction is, it involves the replacement of the diazo group by CN, Cl, or Pr. So this is of course not the Sandmeier's reaction, and hence the correct answer. It's the same reaction. A is aniline, and this is benzene diazonium chloride, and then you carry out the coupling with A itself, that is aniline, right? So the coupling of diazonium chloride, benzene diazonium chloride with aniline, it gives you para amino azobenzene, and which is yellow in color. So this is the correct answer. The coupling of phenol with benzene diazonium chloride is an example of electrophilic substitution of phenol. Correct statements about benzene diazonium salts are A and C, because benzene diazonium fluoroborate, they can be isolated as dry solids, so that technically they are stable at room temperature. Reagent used to convert benzene diazonium chloride to benzene, of course it is reduction, so we will use a reducing agent which is H3PO2, right? The others will lead to the formation of phenol. An aliphatic organic compound containing carbon, hydrogen, nitrogen, hydrolysis with dilute HCl produces formic acid. Then remember, isocyanides on hydrolysis produce formic acid, right? And the primary amine. So the correct answer is this. And it is reduced to dimethylamine. Of course, when CH3NC is reduced in presence of platinum and hydrogen, it will be reduced to CH3NHCH3. Okay? CH3NC on reaction with HgO, it gets oxidized, and then it gives you methyl isocyanate, which contaminated, which was a notorious substance in Bhopal gas tragedy. So that is the correct answer. Which of the following substances on treatment with P2O5 gives propanediol? It is a strong dehydrating agent. So when propanamide, which is this compound, when you treat this compound with P2O5, dehydration occurs, and you get this compound, propanediol. So this is the correct answer. Identify correct statements from the following. A, B, and C are correct. Lower aliphatic amines are gases. They have fishy odor. They are soluble in water because of hydrogen bonding. But pure aniline is colorless. It turns of this color because of the atmospheric oxidation. Right? That's the correct answer. The correct order of increasing boiling points is this one. Secondary, it has a decent amount of hydrogen bonding as well as molecular mass. And then tertiary, because of the molecular mass, and primary, the least. The correct order of decreasing basicity. So you have to sort them out into aromatic amines and aliphatic amines, right? That is the way we do them. So this is of course aliphatic amine, this is aromatic, this is aromatic, this is aromatic. So first is going to be most basic. Now out of second, third and fourth, we know that electron donating groups increase the basicity and methyl is electron donating group. So then fourth and then second, and NO2 is a very powerful electron withdrawing group, it will decrease the basicity of aniline. So third comes last. Freezing point of wave water is this. It is something you should memorize. Calgon is a salt of HPO3. Calgon is sodium hexametaphosphate. So this is Na6PO3 6, right? So it is an anion of HPO3. Which of the following hydride is electron precise, which neither have vacant orbitals nor do they have a lone pair of electrons? Of course, group 14 hydrides are electron precise hydrides. So methane is the correct answer. A mixture of camphor and NaCl can be separated by sublimation. Yes, because camphor sublimes. A very common adsorbent used in column chromatography is anhydrous alumina, Al2O3. You guys know that. So this is used as an adsorbent. The name of CH3CN is all of these. You can call it acetonitrile, common name, or methyl cyanide, which is also common name, and ethane nitrile, which is the IUPAC name. Which is not a property of solids. Of course, solids can be of two types, crystalline and amorphous. So this one is not the property of solids. Certain physical properties of crystalline solids show different values when measured in different directions, and this is known as anisotropy. So fourth, A matches with fourth, SiO2 is a covalent solid, and then B matches with third, CO2 is a molecular solid because it is a molecule, C matches with second because copper is a metal, so it will be a metallic solid, and NaCl is an ionic solid. In a compound, nitrogen atoms involved in cubic close packed lattice, that is 4, and metal atoms, they occupy one third of the tetrahedral voids, right? So for 4 atoms per unit cell, you will have twice as many tetrahedral voids, and one third of them are occupied. So this is of course 2 by 3 is to 1 or 2 is to 3. So that is the correct answer. Crystal structure of monoclinic sulfur and glauber salt is same, so you should remember that the cell parameters, unit cell parameters for a monoclinic unit cell is this. You should remember the edge lengths and the interaxial angles for all 7 types of crystal systems. They are generally asked. The intermetallic compound LiAg. So you can assume that if lithium forms a simple cubic arrangement, then silver is sitting at the body center, or vice versa. So the entire arrangement can be said to be a BCC atom arrangement. So this is the correct answer. AB is an ionic solid. The ratio of ionic radius of so this is precisely the radius ratio, radius of cation divided by radius of anion, and this is 0.52. So it comes under the category of 0.414 to 0.732. So which is of course octahedral, and the coordination number is 6. Total number of primitive or simple unit cells possible for 7 crystal systems are 7. You should remember that primitive is the only type which is possible in all 7 crystal systems. The systematic name of this compound, it is symmetry. You can name it from any side. So 1, 2, 3, 4, 5, 6, 7. Now, because the substituent is itself branched, so such substituents are called complex substituents, and there are a different set of rules for naming such substituents. The carbon atom which is directly joined to the parent chain is numbered 1 and then 2. So the substituent would be 1 methyl ethyl because it is itself a substituent. So 1 methyl ethyl, and to which carbon of the parent chain it is attached? 4. So 4, and we place complex substituents in parentheses, small brackets, right? So 4 hyphen 1 hyphen methyl ethyl, bracket close, and then heptane. So that is the proper IUPAC name of this compound. The structure of propane 1,2,3 tricarboxylic acid. So remember, we've used oic acid when the carbon of the carboxylic group is included in the parent chain, but if you are not including the carbon of COH in the parent chain, then the suffix changes to carboxylic acid. So in this compound, technically the parent chain is this 1, 2, 3, right? This is the parent chain, and all three carboxylic acids have been treated as substituents. So propane 1, 2, 3 tricarboxylic acids. Okay. The correct statement regarding the comparison of staggered and eclipsed conformations of ethane is, of course, this one, because in staggered conformation, the dihedral angle is maximum. This is the staggered conformation. So the torsional strain is minimum. That could be. And in eclipsed conformation, the meaning of the word eclipse, the substituents are right behind each other. So here, of course, the torsional strain is maximum. So this is the correct answer. Number of possible open chain structural and configurational isomers with the molecular formula. Configurational includes stereoisomers and C4H8. If we find out the degree of unsaturation, then C4H10. So we need two more hydrogens, which is actually equivalent to 1 degree of unsaturation. So there is either one ring or double bond, but because we are talking about open chain, so we can only include double bonds. So you can take but 1-ene or but 2-ene, and there would be one cis and one trans, or you could take 2 methyl propene. So in total, there are 4 isomers having the formula C4H8. So that is the correct answer. D-tartaric acid and mesotartaric acid are pair of diastereomers. Remember the stereoisomers which are not related to each other as mirror images, they are diastereomers. So mesotartaric acid will have a plane of symmetry. All right. So this is mesotartaric acid. You can easily observe that there's a plane of symmetry. And the D-tartaric acid, in which one of the these OH groups are on the opposite side. So of course, they are not related as mirror images, and hence they are diastereomers. Metamerism is exhibited by the bivalent functional groups, but aldehyde is a monovalent, right? It only binds on one side, so this cannot show metamerism. Which of the following compound is not possible? You can only guess the correct answer just by looking at the formula. For a ketone, you need at least 3 carbon atoms. Otherwise, you can check this would be the correct answer. So that's all for guys. Thank you.